All right, so in this video, I want to solve this trig identity over here, or prove it, I guess. So if I look at this trig identity, the left side is more complicated. So I'm going to start by working with the left side. Now, there might be a couple of ways to do this problem, but if you notice over here, this is a sum of cubes. I mean, technically the exponent is 6, but we can still do sum of cubes on it, because if the exponents are cube rootable, which are in this case, and they're added or subtracted, we can do sum or difference of cubes. So if I do sum of cubes on this, the cube root of this equation is sine square x plus cos square x, and then the second bracket, my first term is the first term here squared. Sine square x squared is just sine 4x. Then I'm going to multiply these two terms. The sign over here has to be opposite of this one. So this is going to be sine square x cos square x. And then the last term is always positive, and it's the last term squared, which is just cos 4x. And we know that sine square x times cos plus cos square x is just 1, and 1 times an equation is just the same thing. So I'm just going to rewrite this equation over here. Don't actually have to rewrite it. You can actually do the next step straight from there, but just to make it a bit more neater and clearer, I will write it out. Now I need to simplify this to get this over here. What I notice over here is I have sine squares and I have a 1, which I know I can get from sine square plus cos square. I want to turn all my exponents into squares. So I'm going to rewrite sine 4x as sine square x times sine square x. I'll leave the middle term the same. And I'll write cos 4x as cos square x times cos square x. Next, I'm going to convert this sine square into 1 minus cos square x. And the reason I've done this is because I know sine square times 1 will give me sine square x, which I can eventually use to get the 1 here. And I also know sine times negative cos is going to give me negative sine cos, which is basically the second term here. So this has to be the right step. I'll leave the middle term the same because that's the same as this over here. And over here, I will convert one of the cos squares into 1 minus sine square x. Again, the exact same reason as the start over here. I'll now get rid of these two brackets. So sine square times 1 is sine square x. Sine square times negative cos square is negative sine square x. Cos square x, I'll write the middle term the exact same. Cos square times 1 is just cos square x. And cos square times negative sine square is negative sine square x, cos square x. Final step, I know sine square plus cos square is just 1. So I can just rewrite that as 1. And negative sine square minus negative sine square cos square minus sine square cos square minus sine square cos square. These are all like terms. If we combine these three like terms, negative 1 minus 1, it's just negative 3 sine square x cos square x. And now we've proved the trig identity because this is the same as the other side.